Okay, awesome. Now we have this p hat. We have a p hat from experimental data, and we're thinking about this p that we're assuming is going to be true. And we're going to see if this experimental data is significantly different from this. So let's remember a few things that we know about p hat. One thing, p hat's a variable. P hat is normal. Just a second. Sorry about that. As long as there are 10 failures and 10 successes, p hat is a normally distributed random variable. There is a mean. P hat is a mean. And the mean of p hat is what the mean of the population is. If we were to look at a bunch of different p hats from a bunch of different samples of size 103, all of those p hats would be distributed around 0.5. They would have a mean of, we're hoping, 0.5. And p hat also has a standard deviation. The standard deviation of p hat, or the book calls it the standard error of p hat, works out to be equal to this formula right here. 0.5 times 1 minus 0.5, which also in this case happens to be 0.5, divided by n, which in this case is 103. The formula looks like this. I'll remind you. P times 1 minus p divided by n. So for our sample, we ended up with a mean of p hat, which is equal to 0.5. We ended up with the standard error of p hat, standard deviation of p hat, which is equal to 0.5 times 0.5. Let's see if I can get this so you can see it easily. The square root, let's turn this guy on, square root of 0.5 times 0.5 divided by 103, about 0.0493. 0.0493. So what, you ask? Well, if we have a distribution of p hats, and that distribution is normally distributed, centered at 0.5, and that distribution has a standard deviation of 0.0493, so let's go like this. This would be 0.5 plus that, so this would be 0.549. This would be 0.5 minus that, which would be about 0.551. So one standard deviation above and below the mean is 0.549 and 0.551. What we actually got was something which was quite a few standard deviations below the mean. What we actually got was 0.437. And we want to know, how significant is this? In other words, how unlikely is it that we would get something which is either that far below the mean or that far above the mean? In order to do that, we're going to be looking at its z-score. Totally makes sense. It's a normal distribution. And we're going to be looking at the area in these two tails. So the z-score of that is the distance that this thing is away from the mean, measured in standard deviations. The z-score is going to be 0.437. That's the individual. Minus 0.5. That's the expected value, or the mean under the null hypothesis. And down here is 0.0493. That's how big a standard deviation is. So it'll be about whatever that is. It looks like it's about 0.063 or 0.0 something like that. I don't know. 0.063 away, but how many standard deviations is 0.063? Well, we can divide by the size of a standard deviation to figure that out. So one more time, let's fight the glare here. We'll go 0.437 minus 0.5. I should put that all in parentheses because I want to divide it by the size of a standard deviation, 0.0493. I press enter, and I get a z-score of negative 1.28. The z-score is negative 1.28. So this p hat is about 1.28 standard deviations from that. We'll deal with finding the p-value in the next video.